Hey everybody, it's Mr. Carr again. Today we're going to be talking about solving polynomial equations. For a lot of the ones we're going to do, we're looking at the algebraic methods here, and there's going to be certain patterns we want to look for. So first of all, these are two formulas that are going to be kind of important for what we do with this. So if you're dealing with perfect cubes, you have the sum of perfect cubes, you can automatically factor it into this format. Okay, so it's going to turn into a plus b multiplied by a squared minus ab plus b squared. If you have the, well, whoops, that's a typo. If you have the difference of two cubes, then it's going to look like this. We're subtracting the two, it turns into this. Just some patterns to kind of focus on. If this is addition, then this is addition for the factoring like that. And then you got inside is going to be a minus and a plus. Okay. If it's a minus here, it's a minus here, those match up, but then it goes opposite here, it's go plus plus. So the final part is always positive, but then this part, these two are always going to be opposite. So it's going to be either plus minus or minus plus, depending on where you started. So let's see how that works when we actually use that. Factor the polynomial x to the third minus 125 if the polynomial cannot be factored right prime. So always check for GCF. We're good here. X cubed and 125 are both perfect cubes. So we can factor the difference of the two cubes. Okay. So the way what we're trying to show here, write each term as something cubed minus something cubed. What we mean by that is if we think of, we got x cubed, that is x to the third power, right? It's x times x times x. I care about the x right there. For 125, I got to figure out what multiplied by itself 3 times gives me 125. The answer is 5. So basically turning 125 into 5 to the third power. That means my two values here, x and 5, I can apply the 2 cubes formula, or not sum, the difference of 2 cubes formula. So I'll write that down again. It's a minus b cubed is equal to, it's a minus b times a squared plus ab plus b squared. So in this scenario, my a is x, my b is 5. So I'm just going to plug those into all those places. So we're going to have x minus 5 right here. And I'm going to have a squared, which is going to be x squared, plus 5 times x, so it's just going to be a 5x, and then plus b squared, so it's going to be a positive 25 right there. And that's it. That's all we're doing on that one to do the factoring. Okay. Over here, we got sum and difference of these cubes here, factor the polynomial here. So just like last time, double check if there's GCF. There is in this case. So I got 24 and 3. That means I could take out, for GCF, I could take out a 3 out of both of those terms. And then between x to the fifth and x squared, I could take an x squared out. So let's do that factoring first. So 3x squared is going to multiply by 8x to the third power plus will be y to the third. 8x cubed and y to the third are both perfect cubes. So now we can factor using our formula. If we think about what is the kind of perfect, I guess, cube root there, this is like saying 2x to the third power, because it's 2x times 2x times 2x, gives me 8x to the third, and then y to the third like that. So again, the reason I want that is because those are technically my a and b's there. So here's the formula. We got a to the third plus b to the third. It's going to factor into a plus b times a squared minus ab plus b squared. Okay, so a is 2x there. I'm going to have 2x, b is y, so I'll have 2x plus y like that. And then for the rest of it, I'm going to have 2x squared. So remember, I'm taking 2x times 2x. That will turn into 4x squared. Minus ab, so that's going to be 2 times x times y, plus b squared. So in this case, it's going to be y squared. Okay, and that's it. That's my factoring from that one, applying that rule. The other thing we can do is, here's one factoring with this case here. X to the fourth minus 29x to the square, x squared plus 100. So if the polynomial cannot be factored right prime, this one is factorable. Here's the kind of trick with this one. You notice how it's 4 and then 2, right? This x squared term, the degree of the other one is double the other one. Almost like if it looked like this. What if I said u squared minus 29u plus 100. Pretty close there, okay? And this actually has a direct connection here. What I'm basically saying with this setup, what if I call u x squared? Okay, so that means if I take u squared, that's x squared to the second power, which is x to the fourth. Here it's 29x squared. Isn't that the same as negative 29u? So this is how I'm going to set this up. Let's factor this quadratic that you've done before. So I do my factoring. We know it's u and u. So we want to say what multiplies to 100 adds to a negative 29. So we're trying to do this idea here. Multiplies to 100 adds to a negative 29. And that's a negative 25 and negative 4. So it'll be u minus 4, u minus 25. So I've factored the u squared expression. Well, let's do this again. Since u, I called that x squared. Couldn't I then take this and replace it in here and here? So that would look a little different. It'll be x squared minus 4, x squared minus 25. Well, now these are the difference of two squares. We can apply this rule. A squared minus b squared is going to turn into, whoops, a minus b, a plus b. So I can do that here with the x's 4 and 25. X minus 2, x plus 2, x minus 5, x plus 5. And that's it. That's my factored form there. So actually, it looks confusing, but I could turn this into this is the goal. Okay, I just had to pause real quick. Sorry about that. All right. For our last example, we're going to factor by grouping. And you've actually already seen this in another video, or I've covered it in class. If we have 4 terms, we want to factor this polynomial, x to the third plus 5x squared minus 2x minus 10. We can do it as a factor by grouping. Anytime we have 4 terms is the idea. So what we do is we're going to group the first 2 sets of 2 and the second 2 terms together like this. So we're going to look at it as x to the third plus 5x squared. And then I can look at it as like, we'll say plus a negative 2x and a minus 10 like that. Okay, so I'm focusing on these 2 and these 2. From there, we're going to factor out the GCF in both sets of parentheses and factor out the common binomial after that. So again, as a reminder, what can come out of x to the third and x squared? X squared. What's left? X plus 5. What can come out of a negative 2x and a negative 10? I can take a negative 2 out. What's left? I'm going to have a positive x here and a positive 5. Since I've done that, these two match up. So I'm factoring that out to the front, so it looks like this. X plus 5 in front. What's left is the x squared and the negative 2, so that goes in there. Okay? So after that, double check, can I factor any further? Well, with x squared minus 2, you can't factor any further, so this problem is finished. Okay? And that is it for 5.5 day 1. All right, take care, everybody.